So good evening everybody, it's from Jayshree. I'm going to take this 555 timer and its applications under the unit of Unit 5, which is a which is under this timer, parallel and A to D and D to A converters. Okay. What I mean by 555 timer? So 555 timer is the monolithic timing circuits that can produce accurate and highly stable delays or oscillation. The timer basically operates in one of the two modes, either monosable multivibrator or astable multivibrator. The important features of 555 timer are: it operates in plus 5 volt or 18 volt supply voltage. It has an adjustable duty cycle. Timing is from microseconds to hours. It has a current output. So next one, this is what the pin configuration of this 555 timer. We can start the pin configuration from left and right, 1, 2, 3, 4, and from bottom to top, 5, 6, 7, 8. So from 1 it is indicated as ground, from 2 it is indicated as trigger, from 3 it is indicated as output, from 4 it is indicated as a reset. At 5, at the pin number 5 we can give the control voltage. At the pin number 6 we can use the threshold. At pin number 7 discharge and VCC. Okay. This is what the pin definition, each and every pin definition of this circuits. Okay. Pin 1, the ground is connected to this, all the voltage terminal measured with respect to this terminal. Okay. Pin 2, the output of the timer depends on the amplitude of the external trigger pulse applied to the pin. Next, pin 3, we can take this output. Okay. Pin 3 is used for output. There are two ways a load can be connected to the output terminal, either between the pin 3 or ground. Okay. Next one is what pin 4. If you want to reset any configuration, we can use this pin 4. In the pin 3, when the input terminal is low, the load current flows from the load connected between the pin 3 and plus VCC into the output terminal, and is also called the sink current. Okay. Next one was when the output pin is high, the current through the load connected between pin 3 and VCC is 0. Hence, the output terminal supplies current to the normally off load. This current is also called source current. The 555 timer can be reset by applying a negative pulse to this pin. When the reset pin is not in use, the reset terminal should be connected to VCC to avoid any false triggering. Next one, control voltage. This control voltage and external voltage applied to this terminal changes the threshold as well as trigger voltage. In other words, by connecting the potentiometer between this pin and the ground, we can get the pulse output waveform can be varied. When not used, the control pin should be bypassed to ground with 0.01 capacitor to prevent any noise problems. And this is non-inverting terminal of the upper comparator, which monitors the voltage across the external capacitor. Next one is what? Discharge pin. This pin is connected internally to the collector of the transistor Q1. When the output is high and Q1 is off, when the output is low, Q is on. The supply voltage of plus 5 volt and plus 18 volt is connected to this pin with respect to the ground. Name this pin as VCC. Okay. This is what the block diagram of 555 timer IC. So here there are two comparators, right? Comparator 1 and comparator 2. Comparator 1 is connected to the bottom of the, top of the circuit, and comparator 2 is connected to the bottom. And the comparator 1, the non-inverting terminal is connected to the input, and in comparator 2, the inverting terminal is connected to the trigger. The input is given to the trigger, and both are connected to the SR flip-flop, and Q and Q bar are the output. This we can get this output signals. This 5K internal resistance act as the voltage divider, providing bias voltage for 2/3 VCC, that is 2/3 of VCC to the upper comparator and 1/3 of VCC to the lower comparator. It is possible to vary time electronically by applying a modulation voltage to the control input terminal. Okay. Next one is what? This is what the stable state. In the stable state, the output of the FF is high. This means that output is low because of power amplifier, which is basically an inverter. Q1 is equal to 1. Okay. Next are the negative going trigger pulse. The trigger pulse passes through VCC and the output of the comparator goes through this high and sets the pin as 0. So thank you all.